Welcome, Aditi.
Thank you. So my name is Aditi and I work with the U.S. Army Research Laboratory. And today I'm going to present on the social and cyber effects of decision making. So our everyday interactions are affected not only by our own decision making processes and actions, but also the spread and evolution of information. So as social interactions become increasingly online through social media, information consumed through this medium shapes how we think. In this study, we examine the neural underpinnings guiding the impact of information and social versus cyber context on decision making, where information credibility varies greatly. So in the study, participants went through 4 scenarios on various topics related to current issues where they interacted with a simulated social media platform that had real and fake news articles relevant to the topics. And then they also discussed the topics with other participants. They were given a questionnaire at the beginning of each scenario after interacting with the simulated social media platform and after the discussion group to measure how their opinion changed after these interactions. And throughout the entire process, they were also wearing an EEG headset so that we could measure their neural electrical activity during opinion change. So I can explain one scenario as an example. The scenario is about vaccination. So the participants started by answering an initial questionnaire that asked whether they would vaccinate their hypothetical child. And then they read articles on the social media platform about the effects of vaccination, some of which were in support of vaccinations and others were against them. And then the participants answered another questionnaire repeating the same question of whether or not they would vaccinate their child. Finally, they discussed it with other participants who also read these articles, and then they filled out a final questionnaire on whether or not they would vaccinate their child. So in order to quantify opinion change, I assigned each participant a score for each scenario from 0 to 1, with 0 being they did not change their opinion at all, and 1 being switching to the opposite opinion. And then I added this up for all 4 scenarios to get a score from 0 to 4 for opinion change. So on the x-axis is their opinion change due to the simulated social media platform, the difference between the first 2 questionnaires. And on the y-axis is their opinion change score from 0 to 4 after the discussion, so based on the difference between the second and third questionnaires. And when I plotted this data, I noticed a slight linear trend, which might tell us that some people are simply more prone to opinion change, regardless of whether they were influenced by social media or in-person social interactions. After this, I divided the participants into groups based on whether they were more cyber influenced, socially influenced, both or neither, so that we could evaluate whether individuals in these different groups also differed in their neural activity. So the hypothesis that drove our analyzation of the neural data was that variability in opinions would correlate with variability in neural activity. So data was captured throughout the study using an EEG headset that placed electrodes on the participants' heads and measured the electrical activity of their brain. And then we separated that data based on frequency into 5 different bands. And once the data was filtered, we analyzed using 2 different methods. The first was traditional power analysis, which measured how each frequency band varied in electrical power. And the second method was the relatively newer networks approach, which measures the variation in connectivity with a statistical relationship among nodes across time using graph theory. And using those 2 metrics I just described, I created box plots of the coefficient variation for each group of participants to determine if these metrics could be used to differentiate groups defined by how they change their opinion. So the results showed that the respective neural pathways of information processing versus digital interaction and in-person interaction were not statistically different, suggesting that similar neural processes serve both types of decisions regardless of whether they were influenced by social media or an in-person discussion. So our results suggest that different scales of neural processing underlying decision-making are at play when individuals are presented with a variety of reliable and unreliable information in different contexts. So going forward, we hope to consider different neural metrics, such as the one that Kristen talked about earlier today, as well as looking into if spatial or temporal activity varies across different opinion change groups. And we also want to further consider how people's opinion change was affected by how much their discussion group varied from their own opinions. And we hope that better understanding opinion change and people's influence by in-person interactions and social media will help us potentially protect people from being affected by misinformation and fake news. And I'd like to thank everyone that worked on this study at the U.S. Army Research Laboratory, DARPA, and Advanced Brain Monitoring. Thank you.
Thank you, Aditi, for the presentation. That was very interesting, and that touches a very relevant topic as well, especially currently with so much social media and discussions and so on. So again, we are welcoming questions from the audience. You can use ideally the Q&A tool in Zoom, or you can ask directly as well in the chat. While we get questions, I have one. So it's not clear to me. So from the presentation, how maybe you mentioned this, but how do you exactly are measuring? How are you exactly measuring the changes in neural activity? Can you say a few more words about that?
So we had them wearing an EEG headset the whole time. Mm-hmm. And the two metrics I looked at here were power. So that was like electrical power of EEG in each of the 5 frequency bands. And then the second one was network strength. So that's based on the connectivity of nodes using graph theory.
So, and I guess from the EEG, you could localize at least roughly the location of the changes in the neural activity. But is there, so because my broader question is, so what would be the interpretation of the changes of the correlation between the change in opinion and the effect on the neural activity? It would be very interesting to know more about all that. So can you say?
So for these particular metrics, it looked at activity across the whole brain rather than like specific regions, but that is something we definitely want to look into to see if there is a difference between groups that change their opinion influenced by different contexts, if they also differed in like which areas of their brain behave differently.
Cool, thank you. So you actually collaborate with each other, Kristen and Aditi?
Yeah.
Okay, that's cool. That's very lucky we have you both. And so what are the directions for future work regarding these studies that you both have presented?
So there, we did like capture more data related to the discussion as well. So like both Chris and I looked mostly at neural activity while they were interacting with the social media platform, but we do want to look into how they interacted with other people in person as well and see how that differed.
Mm-hmm. Do we have time for another question from me? Just
absolutely, yeah.
I have 2 kind of technical questions. One is, how do you guys make sure that the people? Okay, I'll ask it differently. Did you look for eye movements, and is it the case that, because if people are looking at those questionnaires, some people who may be more anxious or something, I'm just making this up right now, but eye movements could have a huge effect on those sort of neural measures, especially if you're just looking at power and it's not really time locked to anything. So have you thought about that?
We have not considered eye movement data.
Just maybe consider like, how like maybe moving around and stuff may actually change those measures. And I don't know anything about, how people change their opinions and stuff, but it might be worth noting that there aren't any other just random physiological things going on that changes that. And then my other question was going to be, you showed the, like your 4 groups. So have you looked at just a correlation rather than trying to group people? Maybe you mentioned that and I didn't hear it, sorry.
A correlation of what?
So, you had your plot and then you made those 4 groups, 1, 2, 3, 4, and then you looked at the changes in brain activity. And I was just wondering, because people are kind of on a spectrum rather than in groups, have you actually just tried to dump everyone together and see if you can see changes that correlate on an individual level with changes in beta and alpha and whatever?
I did try that. I haven't found any significant results there.
Cool, thank you.
Okay, we have one question from the audience. Alisa Moore is asking about if you analyze the specific content of the articles and also the discussions between the participants to see what is the type of information that might be driving the change in opinion.
Yeah, so opinion change across the 4 different scenarios did vary greatly. Like some scenarios, people were just like less likely to change their opinion. So I think we should go back and look at like how the particular context of the scenario and the information they were looking at affected their general opinion change.
Mm-hmm. But so is it like, do you have like different categories of the, of social media articles or is it kind of general?
Yeah. So like each scenario of the 4 had a lot of articles associated with it, about half of which were like in support of the topic and half which were against it.
Mm-hmm. Okay.